Hello and welcome to the video on how to write your question and hypothesis for your science research project. So we always start with the question. The question comes before the hypothesis. It is defined as something that can be answered by designing and conducting your experiment. If you're doing a scientific method versus the engineering, it's going to start with the question. So you, as the researcher, will make observations or do research to find a problem that you will develop into a question. And this makes sense because if you are looking at science topics and stuff that you're interested in, you're naturally going to have questions about how those things happen, what happens when this affects this, stuff like that. So you are going to naturally have questions about topics you're interested in. So we need to write out a good question first. And that question has to be testable. And it should include a dependent and independent variable. So we'll talk about that. So a good scientific question is one that can have an answer and be tested. So we need to make sure that it is something that can be answered using an experiment. So why is that a star? Is not exactly testable. But what are stars made of? That's definitely a better question. That's something we might be able to get an answer to. Like I said before, it has to be testable. Here's some examples. Pepsi doesn't have more carbonation than Coke. So that's something where we can experiment with Pepsi and Coke and verify and see which one has more carbonation. The effect of cigarette smoke on lung cancer, that's something we could experiment with and get an answer to that question. Things like opinions, pink being the best color in the world, that's not something that we can test. We can't experiment on pink being the best color in the world. So this is not a good question for your research project. Another thing that happens when you write your question, it needs to build on what you already know. So if there's a topic that you already know a lot about, don't make it your question something that you already know the answer to. You can have an educated guess of what's going to happen in the experiment, but it needs to build on what you already know. So if you already know what's going to happen, make it something more specific. So instead of saying, well, fertilizer make grass grow greener, why don't you use at what concentration of a certain type of fertilizer will the grass grow greener? Another thing about good questions is it leads to other good questions. You guys are very good at this. When someone asks, why does that, blah, 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 another student will ask, well, why does blah, 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 blah? So always want to build on other good questions. Make sure that when you get your answer to your experiment, someone else can do another experiment on something more specific or a different area of that answer, like this example. Another thing about good scientific questions is that they can be tested by an experiment. We've talked about this the entire time. But here's a good example. Where does the sun come from is not necessarily something we can test. Okay? But how will human skin react to solar radiation, where one participant is covered in SPF 30 and the other is not covered in any sunscreen? So that is something that we could easily experiment with. Okay, so these questions should be framed in a way that it can be tested. All right, it needs to obviously be in the form of a question. So you're not going to want to say, I want to know if the sun is yellow? First of all, it's in first person. Second of all, it's not in the form of a question. So that's two things right here that we shouldn't be doing. It needs to include the dependent and independent variable. So, for example, this has, what effect does sunlight have on the chlorophyll content of sweet pea plant leaves? So that has an independent and a dependent variable. It is not in first person, and it is in the form of a question. And that's something that we can test. We can get some sweet pea plant leaves and put sunlight on it, and we can measure the chlorophyll content. Okay, so once you're done with your question and you make sure that it meets all of those requirements, we're going to work on the hypothesis. So, as we know, it's not just a guess of what's going to happen. It's a tentative, testable answer to a scientific question. So you want to make it after the question. I mentioned that before. And after research has been done on the problem, the question is addressing. So you want to make sure there's something going on there that you can develop, go back to this, a tentative, testable answer to that question that you just made. So here's some examples. Why do leaves change colors in the fall is your question. And your hypothesis might be something like, I think leaves change colors in the fall because the exposure of less sunlight, there's less sunlight exposed to them. Another hypothesis, bacterial growth may be affected by temperature. Chocolate may cause pimples. So you are answering the question with your tentative, testable hypothesis. So these use may, but the form of these that we have here is not very specific. So using the word does not suggest how you would go about proving it. If these statements had not been written carefully, they may not have been hypotheses at all. Hypotheses. So this is the if-then format that most of you have seen in your science classes before. Here's some examples. Basically, it's an if something happens, then something else will happen, right? So that's the normal format. If skin cancer is related to ultraviolet, then people with high exposure to ultraviolet will have a higher frequency of skin cancer. Okay, so you're not using first person, of course. It has if and then, and it contains the independent and dependent variable. So most of you probably know the difference between independent and dependent variable. We go over that in science class every year. But independent is the variable that you are controlling. All right, so in this case, it's the high exposure to UV light. So it's something that you can turn up or turn down, or expose or not expose. It's the thing that you are controlling as the experimenter. The dependent variable is the thing that responds to that change that you're making. So the one you observe and or measure the results of. Most of us know that. So we at Edgewood, we have our own format for the hypothesis. So we always want to say the results of the experiment will show. So you can go ahead and write that down for your hypothesis. That's how it's going to start. And then we're going to do the if-then format. So the results of the experiment will show if skin cancer is related to ultraviolet light. Hold on.
I wanted to say thank you so much for a fantastic week. Also, thank you so much, teachers.
Okay, so we're talking about the official Edgewood format. It's definitely going to say the results of the experiment will show, and then you'll have your if-then statement. This is your hypothesis about what's going to happen in your experiment. And that is it for the question and the hypothesis. If you have any questions about specifically your topic that you're going for, please let your research teacher know. Hopefully this video was helpful.